All right. Hey, everybody. We are going to be learning about dimensional analysis. And so follow along with me on these slides. I would say write down everything and be sure to do all of the sample problems as we move along. So feel free to pause this in order to get down everything, and then you can listen to me explain it either before or after. So we learned about dimensional analysis actually at the beginning of the year. And so dimensional analysis is a method that is used to convert units. So if we are thinking about these different amounts right here, we see here the stuff that I'm highlighting. These amounts, right, need to be converted between units. So minutes is a unit and hours is a unit. Hours is a unit, days are units. Centimeters, meters, inches, feet, ounces, pounds. These are all units, and in dimensional analysis, the main goal is to convert one type of unit to another using what we call conversion factors. So conversion factors are like what is equivalent, right? How can we go from minutes to hours? Well, we need to know that there are 60 minutes in an hour. How can we go from hours to days? Well, we need to know that there are 24 hours in a day. How many centimeters are in a meter? How many inches are in feet? These are things, so all of these are conversion factors. So if we wanted to convert units from, like, let's say a problem, we want to find out how many hours are in 252 minutes. We would set up a conversion factor, a problem that uses this conversion factor to give us what we want to know. So the steps for solving a dimensional analysis problem are as follows. You write the known, like what we know about a problem, and we put the find, what we want to find. We write our known quantity, what we are given, over 1, over the number 1. We use as many conversion factors as possible to convert what we know into what we want to find. Then we multiply through the top and the bottom to reach our final answer. So here's our first example, right? The question is, how many centimeters are in 2.7 meters? Our known is 2.7. We want to find question mark centimeters. So we know we are looking for some number, but the unit is centimeters. We need to use some conversion factors in order to go from meters to centimeters. And we know that 1 meter is equal to 100 centimeters. So like we said, we have our known, we have what we want to find, we know our conversion factors. We're going to go back to step 2. Write your known, put that over 1. Oh my God, we know 2.7 meters. We're going to put that over 1, like in a fraction, right? So we've got 2.7 over 1. We are going to multiply this by our conversion factor. Now, what we want to do is be sure that in our conversion factor, our units are able to cancel, right? So we want to be able to diagonally align our units such that we can cancel out what we have. And these little arrows show us, sorry, these little slashes show us that meters and meters can be canceled. So we have 2.7 meters times 100 centimeters equals 270 centimeters. And this is our find. We found the answer, 270 centimeters here. Here's another example. How many feet are equal to 54.7 inches? So our known, what we know is here, 54.7 inches. Our feet, or our find, is question mark feet. So we want to be able to find how many feet are in 54.7 inches. Our conversion factors are here. There's 12 inches and 1 foot. So we've got 54.7 inches set over the number 1. We are multiplying it by our conversion factor, set up such that our units can cancel out. Inches can cancel out inches Inches can cancel out inches. Boom. And then we are left with what happens when we actually divide the top number by the bottom number, right? 1 and 1 cancels. Basically what we're doing is we're taking 54.7 divided by 12. We are getting 4.56 feet. Now, sometimes you won't always know what the conversion factor is. So let's look at this chart. This shows us the prefixes. So how many anything, centigrams, centimeters, centiliters are in whatever our base unit is. So our base could be grams, liters, meters. So how many millimeters are in a kilometer? And this is how we are using our conversion factor. So we know that we can convert a millimeter to a kilometer by saying it's 1 in 1,000, right? There are 1,000 meters in a kilometer. So we are raising it to the power of 3 from our base, but then we need to go back and then incorporate our millimeters. So it's actually going to be times 10 to the 6 millimeters to kilometers. 3 from here and 3 from here. So a chart like this is going to help us go from something like grams to kilograms. Let's look at our next unit here. Let me get these slashes out of the way for a second. So this is a two-step conversion. The problem says how many kilograms are equal to 45,000 milligrams. So we have our known here, it's 45,000 milligrams. 45,000 milligrams. We want to find how many that is in kilograms. So we're looking for our answer. It's going to be an unknown number with the unit kilograms. We are using our conversion factors. There are 1,000 milligrams in 1 gram, and there are 1,000 grams in a kilogram. So we are taking what we know, 45,000 milligrams, we are putting that over the number 1. We are then multiplying this whole fraction by our conversion factor such that the units cancel. So we are putting our 1,000 milligrams over grams. Guess what? We can cancel out our milligrams now. Boom. We want to set up another conversion factor so that we can cancel out grams. Grams goes away and grams goes away. So we've got 1,000 grams in a kilogram. The unit that we are left with, look at all of these other units have been canceled out. The unit that we are left with is kilograms. What we need to do is multiply through. So 45,000 times 1 is still going to be 45,000. And we are going to divide that by 1,000 times 1,000. So 45,000 divided by 1,000 times 1,000 is going to give us 0.045 kilograms. We want to make sure that whenever we go from one prefix, like milligrams, to another prefix, kilograms, we do 2 conversion factors just to keep our decimal points and our units the same. Here's another example of something that uses 2 conversion factors. And once again, let me just get our slashes out of the way here. So here we go. Here's all of our slashes. The question asks us, how many seconds are in 1.5 weeks? So our given, that's our known. Our know is 1.5 weeks. 1.5 weeks. And we want to find how many seconds that is. Our conversion factors are listed here. There are 7 days in 1 week. 1 day equals 24 hours. There are 60 minutes in 1 hour. And there are 60 seconds in 1 minute. We know all of these. These are not something that we need to look up. But if you were unsure of your conversion factor, you could go to Google and ask how many grams are in a milligram, how many decagrams are in 1 gram, etc. Moving on with this problem though, we are starting with our known. We have 1.5 weeks. So 1.5 weeks, we are gonna set that over the number 1 and multiply by each one of our conversion factors. So we're gonna start with 1.5 weeks. We wanna multiply by the next conversion factor, the one that breaks down weeks into a smaller unit. 1 week is equal to 7 days. So we've got our weeks are canceled. Now we are working with our days. Are we in the unit that we want? Are we in seconds yet? No. So we have to keep adding our conversion factors and setting them up such that the units cancel. So how do we get rid of days? Well, we break down that unit a little bit further into hours. How do we want to get rid of hours? How do we want to get rid of hours? We go by minutes. So hours is now canceled. And then finally, we cancel out our minutes. Minutes is canceled. So what we are left with, the unit that is not crossed out, that doesn't have any tick marks through it, is seconds. And then we multiply all of these together, all the one that's on the top row. 1.5 times 7 times 24 times 60 times 60, 907,000 seconds. Now, the reason that we didn't divide by anything in this one is because every single number on the bottom is 1. Here's another example for you. The Empire State Building is approximately 381 meters high. This is our known, 381 meters high. How many miles is that? So we need to do a bunch of conversion factors because we need to go from meters to centimeters, our metric system, and then we need to convert it into inches based on what we know. We need to go from the metric to the imperial system and then to miles. So the easiest way to do this is through our conversion factor of 2.54 centimeters per 1 inch. So we need to go from meters to centimeters to inches, back out to feet, and then finally to our mile. Here's all of our conversion factors. We are setting up our equation. 381 meters, we're multiplying that by our conversion factor of 100 centimeters per meter. We want to get rid of centimeters, so this is actually should be a decimal point. There are 2.54 centimeters for every 1 inch. And then we need to get rid of our inches. We know that a foot has 12 inches in it. Now our inches are canceled out. 1 mile equals 5,280 feet. Boom. What we are left with is a mile. We multiply our top number, so we have 381, divided by 2.54 times 12 times 5,280. And then once you've got 381 over this, whatever this number is, you're gonna get your final answer here. So what you are gonna wanna do is do this practice right here. I've given you a couple of examples. How can you tell me how much a basketball weighs in grams? We think it's about 1.35 kilograms. How can you use dimensional analysis to figure out what the mass is in grams? Oh, don't worry about this. Okay. All right. Well, thanks for listening. If you have any questions, please reach out via email. And yeah, thanks so much. Have a great day.